right, so again, we're doing 7-5, linear programming. So we're going to do one problem here, then we'll do a problem from your book, and then you have a couple of more problems in your textbook tonight for homework. So, your objective, we're going to solve some linear programming problems. It's essentially a lot, well, the break-even problems that you had in your homework last night, this is kind of a step up from that. So look at example 1. Excellent, it's a step up. A merchant plans to sell 2 models of, okay, we don't buy compact disc players anymore, so you're going to change this to a game player. Does that sound better? Well, you know, it's like a no. I don't care what it is. Some sort of an electronic device. There are many of you that still have the PlayStations and the whatever. So this is a similar cost. So, guys, let's stay focused. So we've got a game player at costs of $250 and $400. We have 2 different game players. The $250 model yields a profit of $45, and the $400 model yields a profit of $50. So it's going to cost the store who is selling it, let's think of it as Walmart. It's going to cost that store $250 to buy it. They're going to make a profit of $45 on it. That's what that's saying. Or it's going to cost them $400 to buy the more expensive one, but they have a higher profit margin. They get $50 on that. Okay? So the merchant estimates that the total monthly demand will not exceed 250 units. This is called a constraint. In other words, they don't think that they're going to have more than 250 items total sold. Both the $250 item and the $400 item. Then it goes on to say the merchant does not want to invest more than $70,000 in inventory. In other words, they really don't have any more than $70,000 to spend on buying these game players. So that is a restriction for them. So this is another constraint. If you don't have the money to buy the product to sell it, are you going to be able to sell that product? Because we've got Joey and Mike over here. Joey's the middleman. You know, if Joey doesn't have the money to buy that calculator to sell it to somebody else, is Mike going to give it to him? Because Joey could just say, you know, I don't have the money to buy it. I don't have the money to buy it, but I'm going to sell it for more, and then I'll just give you percent off of that. Do you think that most middlemen are going to go for that? No. No, because all of the, they're taking all of that, why can't I think of the word? No. No. No, you're not even close. No. You're not even close. I'll come up with it. I don't know why it's again. I don't know why I can't think of the word. It's crazy. All right. You're going to find the number of units with each model that should be stocked in order to maximize profit. So a whole company's goal is to maximize their profit. But instead of selling one item like we did with our break-even analysis, we're selling 2. So it requires a little bit more analysis. So you're going to define your variables. So let's let X equal our $250 game unit. And so what does that make Y? Yep. And that would be, I guess, sold. Number of sold, right? That's your very first step. You want to define your variables. What is it that we're talking about? What are we going to let X and Y be? Then you have to come up with a profit equation. How are they getting profits? So, tell me how they're getting profit. How are they getting profit on the $250 game? What is their profit? $45. So don't they get $45 for every times X for every $250 game that they sell? Right? And then you're going to add to that any profit that they get from the $400 game. So what's their profit on that? $50. So we get $50 for every $400 player sold. This is how they figure out their profit. Oh, thank you. Then we have to talk about constraints. So we know how to get our profit. Now that profit is constrained. The first constraint, and before we write in the box here, we're going to write our constraint over here first. So the first constraint says that the merchant estimates that the total monthly demand will not exceed 250 units. What won't exceed 250 units? Yeah, so if I sell X amount of $250 games plus Y amount of $400 games, that will not exceed. Is that, would I put that 250 units at the ceiling or the floor? In other words, if I put it at the ceiling, I can't go higher. If I put it at the floor, I can't go lower. Where does it belong? Since it is a cannot exceed, what doesn't belong at the ceiling? If it's at the ceiling, I can only go less than that. Do you see where I'm getting from? We have an inequality coming in there. So we have to be less than or equal to, I can be equal to the 250 units, right? Can I put that into my calculator like that? You have to solve it for what? Y. If I solve this for Y, doesn't the constraint over here become Y is less than or equal to negative X plus 250? So that one has a negative slope. Because essentially I could sell no $250 units and I could sell no more than 250 of the $400 units, right? Or I can sell no $400 units and sell 250 of the $250 units. Does that make sense? Or somewhere in between. And that's what that line is going to show us. So it's going to hit the y-axis at 250 and the x-axis at 250. And it's going to go in a negative direction. Then we have the second constraint. The merchant does not want to invest more than $70,000 in inventory for these products. This is a cost to him, isn't it? Not a profit, it's the cost. So what does it cost him to get the $250 unit? That's a trick question. It costs him $250 to buy the unit, right? He's going to actually sell that unit for $250 plus 45. So, but it costs him $250, doesn't it? $250 per every of those units that he buys, right? So if he buys one unit, his cost is $250. 2 units, his cost is $500, and so forth, right? Then I'm going to add to that any $400 units that he buys. So the cost for him there is $400 per however many units he buys. We want that cost, that total cost. Is it less than or greater than 70,000? We want it to be less than. Could it be equal to? Yeah. So there's another constraint. We need to solve for this one, don't we? So this is constraint 1, this is constraint 2. We have to solve this for y. Wouldn't we have 400y is less than or equal to negative 250x plus 70,000? And then we're going to divide each of these by 400, right? You will get y is less than or equal to negative. This will reduce to 5/8 x, and this reduces to plus 175. Okay? So that's what I'm going to put over here. Y is less than or equal to negative 5/8 x plus 175. Now, to be perfectly honest, if on a test I ask you for your equations for your constraints, if you give me this one versus this one, I don't really care. I really don't care. This is more useful in your graphing calculator. This one or this one, I don't care which, but you're going to have to use these ones in order to graph them anyway. So it doesn't, your book is going to probably ask for these ones as your constraints, but to me it doesn't matter. This makes more sense in the real world as to how we came up with them. Question? Why isn't what 205? Doesn't it cost me $250 to buy it? No. The $250 model, it says the merchant plans to sell 2 models at cost of. So it's costing him $250 and $400 to buy those. He's selling them for $250 plus 45, so he's selling it for $295. It's business talk. Now, let me ask you this. There's two more constraints that haven't been mentioned directly. These are the major ones. What kind of a number can X be? Can it be 0? Yes? Can it be negative? No, you can't have negative units. There's no such thing, right? So in the real life, X is actually constricted to being, X has to be greater than or equal to 0. That's another constraint. And then what about Y? Y is also constricted to being greater than or equal to 0 because it's the same thing. They also do have to be whole numbers, but we'll deal with that when we look at our answers if we need to. You're right. I can't sell a portion of a unit. I only want 2/3 of a unit. Can you cut it? Yeah, it's not going to work. It's like buying 2/3 of a box of Girl Scout cookies. Have you ever tried that? The little girl would be looking at you like, what? Maybe little tears would come down her face. I don't know how to do that. You cannot buy a partial Girl Scout cookie box either. Question.
Obviously, this would be on the test.
Correct. The problem will not be broken out like this for you, but it might ask you for parts of it, and you'd have to know to get the other parts. All right, so we're going to put this into our calculator. Now we're going to have to adjust our viewing window and be smart about it. But we're going to go ahead and put it into our, I got to clear out our problem that we did earlier, right? All right, so clear out anything that might be in there. And then I'm going to put this in. So negative X plus 250. I'm going to put this one in. You've got to use parentheses for this one. Your coefficient must be parentheses -5 divided by 8 and parentheses. Otherwise, your calculator's not going to read what the proper coefficient is. And then X. And then plus 175. And then I'm not going to put in the X is greater than or equal to 0. So I can't really put that in here. And I'm not really going to put in the Y is greater than or equal to 0. We're going to take care of that with our viewing window.
Do we have to write this on the test?
Yes. Yes. All right, so if I look at my window, well, let's just look at our window here. Let's fix our window to just a normal viewing window because this is what we use for that problem out of the book, right? -10, 10, 1, -10, 10, 1. That's our standard viewing window, right? Look what happens. See it thinking off here to the side? And nothing. Did I do something wrong? We just can't see it, right? Remember what we said about this one? It's got a negative slope. It's going this way. If I buy 0, remember over here, if I buy 0 $250 units, I'm going to have 250 $400 units. If I buy 0 $400 units, I'm going to have 250 $250 units. What? That's a mouthful. So I know that on my x-axis, I have to be out at least 250. And on the y-axis, I have to be out to 250. And I know that the negative axes aren't going to exist, right? So go to your window. And let's start messing around with it. My x minimum should be 0, shouldn't it? What do you want to do for your x max? Well, let's try, since it's at 250, let's just go out to 500. Let's go out to 500. What do you want to go by? If you go by hundreds, you only have 5 hash marks. Let's go by 50s. That would be good. And x or y minimum, what's that going to be? 0. And what about x, y max? Same thing for 500? And then our scale is 50. Let's see if that helps us any. Oh, look, there it goes, right? There's one. Oh, look, there's the other. Do you see where they're intersecting?
Mm-hmm.
It's, look at your, if yours has an error, look at your equations and see, did you use a parentheses?
Yeah.
Did you use a negative and not a minus? Okay. All right, now we might want to adjust our viewing window because we're going to have to see what this intersection is. And by the way, isn't this y equals 0 right here? And isn't this x equals 0 right here? So we're going to go ahead and we're going to put in our less than and equal to sign. I want you to see what it looks like. And would you like to extend out your window a little bigger? Okay. So go to your window. If we really didn't need 500, we could go to 300, right? And we could go by 25s. 300 and go by 25. There's that. Well, that's nice and bigger, right? So that's nicer looking. I like that. And then let's go into our y equals again, and let me show you how to get the less than signs. See this little slash right over here? You're going to scroll left until you see it. See how it's flashing up and down now? It's getting all excited. Hit your enter button. Hit it once, it looks like that. It's not what I want. Hit it twice, that's greater than. That's what I want. No, less than. Sorry, that's not what I want. Now it's less than. So then hit your scroll button down, and now it's held steady. Now the second one's getting all excited. So I want that one to be less than. So I'm going to hit my button 3 times, and voila, I'm done. Now hit your graph, and a fun thing occurs. Look at that. Isn't math wonderful? And then where all the little squares are, that is the area in which we can hold to our constrictions, and I can buy products in this area, and I will meet my $70,000 limit on inventory, and I will meet my, and I will not exceed the 250 units. In other words, I don't want to buy more than 250 units because I'm not going to sell them. So let's see what the question actually asks. It's asking what's the maximum profit. Oh, maximum profit. We haven't even considered that yet. So how does that work? We want to look at all the points here of intersection. So this is actually a point of intersection, remember, because that's y equals 0. I'm sorry, x equals 0. And this is y equals 0. So this is a point of intersection. This is a point there. This is a point there. So we're going to go ahead and graph this, or sketch this graph over here. So let's do our best. I know it's not on graph paper, so it's going to be somewhat difficult, but we went out 300, right? And how many hash marks did we have? 12, because we went 4 quarters, right? So this is 300. 200. So remember, the x-axis represents the $250 units. That's the number of $250 units. And then the y-axis is going to be my $400 units. Mine didn't go all the way up to 300 on the y-axis. Don't let that bother you. It's not going to become important. So first of all, this line right here is at 250, and that's at 250 down here. If you don't know, trace. So I have one line. $250, and this is at 250. Straight edge. And then I have another line here, this one. If you go and you look at here, won't the y-intercept be at 175? Right? And then I have to figure out what the x-intercept is. So if you want to kind of estimate what that x-intercept is, trace it right here. So I'm going to hit calc. Oh, I didn't want to do that. Oh. So I'm about 280-ish, give or take, when I trace it. Doesn't have to be ultra exact. So we want to label these lines. So this line here is my first constraint, y equals negative x plus 250. And this line here is y equals negative 5/8 x plus 175. And then all of this shaded region is what they have in common. So there's an ordered pair right here where those two intersect, don't they? I need to know what all these ordered pairs are. This ordered pair over here, we know is 0. I'm going to put that in pink. This is 0, 250. I need to see all the points at which borders this region, this polygon, so to speak. Then this point here, I'm going to find the intersection between my purple and my blue line. So what I'm going to do is I'm going to hit intersect. Second count, intersect. And you can kind of see it flashing on, I saw it flashing there somewhere. Oh, there it is down there. And then so that's the first curve, and then the second curve it now jumped to the other line, and then all I have to do is hit guess, and what does it say? 280.85. Oh, no. Oh, really? I thought it did. Oh, yeah, you're right. All right, so my intersection is 2050, right? 200. I'm sorry, 200. 250. And then this point right here, we said was going to be, oh, this one's not 250. What is this one? 175. Sorry. This one is 250, 0. So do we, and of course we have 0, 0 here, right? So there's all our points of intersection, or our critical values. So we have 4. You might want to list them out here. Critical points are 0, 175, and then we go down to 0, 0. And then we go over here to 250, 0, and then 250. So here's what you're going to do. You're going to analyze it over here. So we're going to take our profit equation, which we haven't looked at yet. We're going to take those critical points and your profit equation. So we're going to let, for when we have 175. You're going to put that into your profit equation. Your profit equation says 45 times x plus 50 times y. So I'm going to put in 0 for x right there and 175 for y. Tell me what you get. 87.50, right? So profit is equal to 87.50. Then you're going to let the next one happen. 0, 0. Profit is equal to 45 times 0 and 50 times 0. If you don't buy or sell any products, what's your profit? 0. So far I have $8,750 versus 0. Oh, I don't like 0. So then we're going to try the 250, 0. And I get, oh, much more, right? So I get a profit of $11,250. So far that's my max profit, right? We have one more to try. We're going to let it be 200 and then 50. So I've got 200 and then 50. What do we get now? I got slightly more profit, didn't I? So therefore, what's your maximum profit? Yeah, so our conclusion is, therefore, if 200 X gamers, right, and 50 Y gamers are sold, profit will be maximized. At $11,500. Now, I have a worksheet that, sorry, we didn't get a chance to do, but it's just like this, but another example that you're going to have to do at home.